Okay, the recording has started. So I welcome all of you guys to this SMP by SAE and ITK. And the topic of this SMP is aerodynamic analysis of an airfoil of an F1 car. So this SMP will be 3 week long, and in week one in each week we will be having 2 sessions. And for this week, for the session one, we will be teaching introduction to the basics of aerodynamics, and in session 2 we will be dealing with understanding various aerodynamic parameter and installation of ANSYS workbench. For week 2 we will be having 2 more sessions. In session 3 we have aerodynamics of F1 car, and in session 4 we have selection of suitable airfoil from NACA database. Similarly, for week 3 we have session 5 and 6. In session 5, we will be teaching CFD analysis of the 2D airfoil of a rear wing in F1 car using ANSYS fluid. And in session 6, we will be teaching and we will be analyzing the results obtained and summarizing the merit of SMP. And at the last of this SMP, we will be giving all of you guys a mini project that you will be doing, and you have to complete that for getting the certificate. So starting with the session 1, introduction to the basics of aerodynamics. So the first question, what is aerodynamics? So any of you guys want to answer? What do you understand by the term aerodynamics? It's written anyways. Okay, so I'll be explaining. So aerodynamics is made up of two words, aero and dynamics. So it's the dynamics of the air, just like fluid dynamics. In fluid dynamics, we learn how the fluid behaves when around the object. In aerodynamics, we learn how air behaves around an object. So that's what is written. Aerodynamics is the way air moves around things. And for to learn aerodynamics, we have to know which forces are acting on a object. Like for this SMP, we'll be dealing with this like aircraft to learn because it is the easiest example to understand the basics of aerodynamics. For a simple geometry and for our level of understanding, only four forces act on a body when it is in air. And that four forces are thrust, which acts in the direction of motion, drag, which acts in which acts in direction opposite to the motion, lift perpendicular to the motion, and weight to the earth due to gravity. So now we will be dealing with each of the forces individually. So weight. What is weight? As you guys all know from 11th and 12th understanding what is weight. From the Newton's second law of motion, we know that weight is m into g, where m is mass of your object. So that's basically it. Weight is just nothing difficult. And what is lift? But unlike weight, lift is a very and complicated force. So it it is a component of the total aerodynamic force that acts perpendicular to the body and opposite of weight. It always acts opposite to the weight and perpendicular to the body, and it is the vertical component of the total aerodynamic force. So if total aerodynamic force is F and this angle is theta, then the lift will be F sin theta. And for any body to stay in air, the lift must be greater than weight. That's just basics, that's common sense. And just as I said, it's a very complicated term, and no theory is able to completely explain the generation of lift. There are many different theories that tries to explain the generation of lift, but not a single theory is able to explain the lift phenomena completely. So coming to the generation of lift, in this SMP I'll be teaching how Newton's law and Bernoulli principle explain the generation of lift. Both of these law have on their demerit, but they explain very well according to our level. So coming to the Newton's law, and especially Newton's third law. Like an airfoil generates lift by exerting a downward force on the air as it flow past. According to the Newton's third law, the air must exert an equal and opposite force on the airfoil, which is lift. So like coming to this diagram, like this is our body. This is like cross-sectional surface area of our body, and these are streamlines of the air. So if you guys don't know what are streamlines are just like magnetic field. These are imaginary lines that we draw to understand the dynamics better. They don't exist, but they are just they are for our visualization purpose. So Newton's law, yeah. So we know from the Newton's third law, every action has equal and opposite reaction. So as this streamline goes, due to the shape of this object, the object pushes the streamline downward because the streamline try to stay attached to the body, so it pushes the object pushes it downwards. And because the object is pushing the streamline of air downward from the Newton's third law, air will be pushing the object with the same force in the opposite direction. So air pushes the object in the opposite direction with equal force magnitude equal in magnitude. So that's basically it. Flow deflection and Newton's law. So any doubts regarding Newton's law or Newton's law explains the generation of lift?
No.
Okay, if there are no doubts, then we'll go with Bernoulli's principle. This idea you have, like this explanation you have also understood in like in class 12 or class 11, I don't know, in class 11, yeah. So like how Bernoulli's principle explain the generation of lift. There are two ways in which Bernoulli's principle explain the generation of lift. There are equal transit time theory and obstruction of the airflow theory. In equal transit time, I'll read it first. Flow over the upper surface is faster than the flow over the lower surface because the path length over the upper surface is longer and must be traversed in equal transit time. This increase in flow speed causes reduction in pressure and hence upward lift. So like this is the diagram that explains the equal transit time theory. So these are two parallel streamlines that attach the object, and in equal transit time theory we assume that both of these streamlines detaches and reattaches at the end of the airfoil at the same time. But because we know from the curvature of the object, this distance, the upper surface distance is longer than the lower surface distance. So because they have to travel longer, because the upper streamline have to travel a longer distance in equal time, so it has to speed up. So like the upper streamline velocity will be higher than the lower streamline velocity. So, and we know from the Bernoulli's principle, mechanical energy remains conserved. So this increase in the velocity of the streamline will be accompanied by the reduction in pressure. So that result in lower pressure at the upper surface of the airfoil and compared to the lower surface. So that's how equal transit time theory explains the generation of the lift. And for the second explanation by Bernoulli's principle, there is obstruction of the airflow. Like similar to the above, it explains the generation of lift using pressure distribution, but it gives a different reason. Similar to above, it gives different reason for increased speed. It argues that the curved upper surface acts as more of an obstacle to the flow, forcing the streamlines to pinch closer together, making the stream tip narrower and hence speed. According to this theory, like when streamlines attack am I audible?
Yes.
So, yeah, where was I? Yeah, because these streamlines have to like they pinch together due to the obstruction by the airfoil. So yeah, because and there is a law in aerodynamics which explain whenever the streamlines comes closer together, they speed up, and that derivation of the law is very difficult. So just understand it. Whenever streamlines come closer together, the velocity of those streamlines speed up. So like hence the velocity of these streamlines above the surface of the airfoil increases, and from the Bernoulli's principle, it results in reduction of pressure and hence the lift. So any doubt in Bernoulli's principle or Newton's law? If there are no more doubts, like we'll be going ahead. The lift equation, like how we quantitatively explain the lift. So like for any body in air, it experiences two forces. Is my cursor visible?
No.
So
Yeah, it's
firstly,
visible. Yes, sir.
okay, okay. Yeah, so like any object in the air, it experiences two forces. The first is ball shear stress that acts tangentially to the surface of the body, the this one, and we always like denote the shear stress using tau. This is not T. This is tau, tau W. The W for wall. This is wall shear stress, and these vector lines denote the distribution of the pressure. And yeah, so like, and if you guys will be having a doubt like, what is this theta? Where is this angle? This theta is the angle between the total aerodynamic force. This total aerodynamic force that acts in this way, this this total aerodynamic force, and the perpendicular to the streamline. So this is that angle theta. So like this will be p sine theta minus tw cos theta. But because these p and tau both are like unknowns and they change airfoil, it is very difficult to calculate the lift force using this formula. So like for simpler surface, we remove these terms and like we simplify this equation, and we include a coefficient ex to which accommodates all these uncertainties, and that coefficient is known as the coefficient of lift. It depends on the angle of attack. The angle of attack will be coming soon. The wing shape, and this is our uh, pressure term. Pressure, yeah, this is a pressure density term. Whereas rho is our density, s is wing surface area, and v is velocity. So the lift force is given by half rho v square into a multiplied by coefficient of lift. And yeah, these are just nomenclature for the streamlines. Just the streamline which is in the front of the airfoil is known as upwash, and which detaches from the airfoil, and at the end of the airfoil is known as downwash. So that's how we quantify the lift force. using coefficient of lift. Any doubt?
No.
No? Okay, we'll be going ahead. So yeah, I was using this term very often, airfoil. So what is airfoil? Like an airfoil is the cross-sectional shape of an object whose motion through a gas is capable of generating significant lift. So airfoil is cross-sectional surface area of any object that can generate a lift, that can stay in the air for a significant amount of time. Every shape produces lift, but airfoil is used to maximize lift to drag ratio. Yeah. So like airfoil doesn't have to be like this teardrop shape. Any shape generates a lift. Even a rectangle can generate, not a rectangle, cuboid can generate a lift. Given, but it depends on, but it will have a huge impact. So it's special object that has a maximum lift to drag ratio. Yeah. So like these are the terms that we use to explain the airfoil structure. So like this is our airfoil, a teardrop shaped one. The surface or the point which is at the front of the direction of motion is known as leading edge, and the point or line at the end of the object is known as trailing edge. And when we join these 2 points, we get a reference lines, are also known as chord line. And our camber line is the locus of the points midway between the upper curvature and lower curvature. Like we take mean of both of these and we join all these points. This is upper surface, this is lower surface. Maximum thickness is just the uh, thickness of the airfoil at which is highest. Angle of attack is like angle between the reference lines or chord line to the relative wind velocity, relative wind direction. Here we have a graph between lift coefficient and angle of attack. So yeah, angle. So as angle of attack increases, our lift increases because the wind pushes the airfoil upward. But there is a point when the force of lift decreases substantially. This point is known as stalling, which we'll be explaining sooner. And this is our drag line. Our drag increases with increase in angle of attack because due to the increase in wall shear stress. Here are just the definitions. Upper surface. Yeah, upper surface is also known as suction surface because the pressure at the upper surface is lower than the pressure at the lower surface. So like it creates a kind of a suction force, higher pressure to lower pressure. So that's why it's known as suction surface. And it is generally associated with higher velocity and lower static pressure. Lower surface, also known as pressure surface, it has higher static pressure. Leading edge, it is the point at the front of the airfoil, this one, that has maximum curvature. Trailing edge, it is the point at the rear of the point with minimum curvature. Chord line, chord line is a straight line connecting leading and trailing edge. Mean camber line, and camber line are same. It is the locus of the point midway between leading and trailing edge. And angle of attack. Angle of attack is the angle formed between reference of chord line on a body to the oncoming flow. And here are two diagrams of two airfoils, symmetrical and cambered airfoil. In symmetrical airfoils, the reference line coincides with the camber line, but in cambered airfoil, camber line is different from reference line. So yeah, these are the terminology that we use to explain the airfoil structure. Any doubts? Guys, you can ask doubt here. Like this is not in your on offline classes. You can ask. I'm also a student. I know like we don't always understand what the professor is teaching. So yeah, you guys can ask anything. So if there are no doubts, like we will be going ahead. Coming to the final forces of the air, two final forces out of the four forces that act on an airfoil: thrust and drag. What is thrust? Thrust is the push. Sorry, it is the push that moves something forward. A smaller aircraft get it from the propeller, whereas a larger aircraft get it thrust from jet engine. So thrust is the force that pushes the aircraft in the direction of its motion. And for like smaller aircraft that like old aircraft that were used in like 1940s and 50s, they used to have a propeller ahead that was used to like give the aircraft the thrust, forward moving force. But in today's time, like in modern aircraft, we have like propeller, two giant cylinders at the wings to give thrust. You That's thrust. Coming to the drag is similar to the lift. It is a combination of different kind of forces, and it is the horizontal component of the total aerodynamic forces that acts in opposite to the direction of motion. It is the result of the two sets that acts on a body. Wall shear stresses, this one that acts tangentially to the body, and pressure stresses, these one. So like how we tau- understood in lift force, the angle theta is defined similarly here. It is the integral of minus p cos theta plus tau w sin theta over a differential area. When we integrate, like we get the total direct force. But similarly in lift, this p and tau w term, it varies. It's unknown and it cannot be calculated for a large body. So similar to drag force, similar to lift, we like clubbed all these uncertainties into a coefficient, and that coefficient is known as drag coefficient, drag force. So like yeah, drag force is mainly due to the result of two kind of forces. Pressure forces of form drag caused by pressure stresses, these pressure stress term, and friction drag caused by shear stresses.
Mm.
So yeah, pressure stress is due to the I will be giving example of this golf ball. So these streamlines comes to the body and get detaches at the end of the body. At, so there is a like these streamlines are not attached sim like this streamline that are at the front of the body. So like there is a vacuum or like suction at the like behind the object. So that's why like it results in a drag force. Like there is higher pressure here compared to the here, so it creates a drag force. And for friction drag is just result of the viscosity of the fluid. It's just like friction. It acts parallel to the surface of the body. Yeah. Dimples are introduced in golf ball to increase turbulence and delay flow separation. It reduces drag and so ball travels more. This is the example of turbulent flow. You guys would be knowing what is laminar turbulent flow. In laminar flow, all the streamlines flow parallelly and there is no mixing. So like if a golf ball is traveling in a laminar flow of air, the flow separation would be occur at 80 degrees, not at 120 degrees. This is example of turbulent flow. So yeah, the flow will detach at 80 degree and there will be a higher, this area will be greater. So in laminar flow, there will be more drag force compared in turbulent flow. In turbulent flow, the flow detaches at the angle of 120 degree. So yeah, and the dimples are introduced to convert the laminar flow into turbulent flow to in, in, to introduce more chaos in the flow of the air and increase, and that's this is Coanda effect. Coanda effect, it is the tendency of the fluid jet to remain attached to the convex surface. So this is nothing like Coanda effect explain the tendency of an air to remain attached to the to remain attached to the surface of the object that is flowing through it. Yeah, like just I explained, the P and the tau W term are difficult to calculate, so we include the uncertainties into a single coefficient known as drag coefficient. And just like the lift equation, the drag equation is similar, only the coefficient changes half rho v square a ct. And like if you guys are having doubt like what is air, like which surface we which surface we use to calculate this drag force, for airfoil we'll be using the this surface area that is parallel to this airfoil. Yeah, like this is turbulent boundary. This is the velocity profile of turbulent boundary layer, laminar boundary layer. In laminar boundary layer, wall shear stress is smaller, uh, as it's shown like smaller arrows, and in turbulent boundary layer, the wall shear stress is greater. So like in turbulent flow, there are larger wall shear stresses. So laminar flow is favorable to reduce skin drag. So like if we want to reduce skin drag or the drag which is caused by the friction forces, we want laminar flow. But if we want to reduce the pressure drag, we want turbulent flow to like delay the detachment of the boundary layer from the object. So that's what is depicted in this diagram. As we increase airspeed, the velocity increases, the Reynolds number increases, and hence this is the region of laminar flow and this is the region of turbulent flow. The pressure drag decreases and the form drag increases. So like there is a optimum velocity at which we operate the aircraft so that it has a minimum amount of drag, which is shown by this dotted blue curve, the total drag curve. So yeah, any doubts? So these are the four forces that acts on an aircraft. Uh, if there is no doubt, I'll be going ahead. So coming to the last slide for today's session, what momentum transfer. What is laminar flow and what is turbulent flow? In laminar flow, fluid flows in parallel layer at low velocity. It is like laminar flow is like ideal gas law. It does not exist, but it is used to like it is used for calculation because it is easier. It can only be approximated using high viscosity fluid and when we high viscosity fluid and low velocity condition. So fluid flows in parallel layer at low velocity and viscous forces are dominant. And in turbulent flow, unsteady and chaotic, high mixing characteristic because as the streamlines go chaotic, there is a very good mixing condition. In laminar flow, there is no mixing. And in turbulent flow, inertial forces are dominant. And that's how we define the Reynolds number. Reynolds number is given by inertial forces to viscous forces. So that is also given by rho VD by nu, which you guys know from your class 12 or 11. So yeah, this is just a daily example of laminar flow and turbulent flow. So that's it for the session one. If you guys have any doubt, you guys can ask now.
How many sessions do we have?
Like this assembly will be 3 week long, and each week we will be having 2 sessions, so 6 sessions in total.
And I guess after the end of every week, like we have assignment or no?
No, you guys won't be having any assignment, but at the end of the 3rd week, we will be giving you guys a mini project that you guys have to do and submit for certificate. But there won't be any assignment.
Mm. It was like a theoretical assignment, or do we have like real world projects, like when the club meeting starts offline?
I didn't get you. Can you repeat?
My question is that our assignment is just like theoretical, or do we have any project like when the club meeting starts offline?
No, no, no. As of now, there are no assignments at the end of week. There's only one project at the end of the assembly. Anyone
Yeah,
doubt?
you'll be having one mini project where
Yeah,
we'll
one
ask
minute.
you to simulate an airfoil using ANSYS Fluent. So you'll basically working on software. You don't have any theoretical assignments for every week. Only one work at the last, and we'll be guiding you how to do it. Any more doubts?
Like if you guys don't have any doubts right now, you guys can ask at any time. Like we'll be glad to help you out, and you guys can contact us at the MS Teams, and we will be sharing this PPT with you guys, so you can read it for later.
One more question from me,
Yeah,
from mine is,
yeah.
like after 3 weeks, we have assignment. Okay, then the syllabus is what we studied in the upcoming 3 weeks, or a different one.
Like there is nothing like
It will be
syllabus.
whatever is. Yeah,
Yeah, Shivastan go.
it's it's basically whatever we did in these 3 weeks. Related to that only, we'll be giving you a mini project. It's just a simulation of either a different car body or a airfoil, which will import the geometries from internet and then and analyzing it on ANSYS Fluent. It will be related to this 3 weeks, guys, 3 weeks assembly, whatever we do in this 3 weeks. So yeah,
Okay.
is it clear for you?
Yes, clear.
Yeah, cool. Anyone else? You guys any doubts?
If you guys don't
I
have any doubt,
guess
we will be winding up.
I guess Jatin, you can stop the recording.
Yeah. Okay.